Now, what are the properties of a wave? Before I begin this, most of the time the easier ones to look at are transverse waves, right? Where the medium goes up and down. And the easiest ones that we want to talk about are simple harmonic. So do you remember when we talked about simple harmonic, we said they were sines and cosines? And that is the easiest way to look at a wave. And so now let's try to develop a wave equation by knowing absolutely nothing about a wave. Do you want to do that? This is fascinating. All I'm going to do is I am going to say, I'm not going to tell you what kind of a wave it is. I'm not going to tell you anything about a wave, except I'm going to tell you that at t equals 0, it exists at x equals 0 at point A. That's all I'm telling you about this wave. Okay? Which means this wave exists at this point. If I write the wave equation at t equals 0, will the wave equation form be this? If psi is just the wave, I'm just using that symbol because everybody uses psi for showing a wave. You can use y if you want, but quantum mechanics, when people get to quantum mechanics and they see the symbol, they think, oh my God, it's a scary thing. It's not. It's just how we define a wave. So all I have told you is that my point in space at time t equals 0 is x equals 0 and y equals a. Okay, can I multiply any equation with 1? Will that change anything? Good. Can I also rewrite this as a cosine of 0? What is cosine of 0? 1. Okay. Can I also write this as a cosine of 2 pi?
Yes.
Okay. Can I multiply and divide any equation by t? Will that change anything? Can I do this? Does that change anything? For a wave, do I know that 1 over period equals frequency? So may I call one of these t's period of a wave? It has the same units, right? Seconds? May I rename this one as t? So may I write this as a cosine of 2 pi t over t? Is my period 1 over f? May I rewrite this as a cosine of 2 pi ft? And may I rewrite this as a cosine of omega t, where omega is the angular frequency. So far, so good? Can I also do exactly the same thing for x? Now, what do I mean by that? Here, can I also do a cosine of 2 pi x over x? Is that 1? What do I call x for a wave? Anybody remember? It's called a lambda, a wavelength. So x for a wave is called a wavelength. Okay? This thing right here is called a wave number. For people who have taken quantum mechanics, have seen this before. So in most situations, when you go into quantum mechanics, you will see a wave function written as a equals a cosine of kx minus omega t. What's the difference between sine and cosine? So if I draw this wave, can you tell me if it's sine or cosine? Why not? What's the difference between sine and cosine? where they start. So did I tell you where this one started?
No.
So is it equivalent to me saying that this is a sine of kx minus omega t? Because I don't know whether it's sine or cosine. So these two are equivalent to each other. The only way to tell them apart is when I tell you, if this is my 0 point, is this a sine wave or a cosine wave? Good. What if I moved this over to here? Is this now a sine or a cosine wave? If it starts at 0, it is a sine wave. If it starts at 1 or an amplitude A, it is a cosine wave. That's the only difference. If I don't tell you where these things start, you can't tell me if it's a sine or a cosine. And you also may have seen it written as e to the I kx minus omega t. Same exact thing. Cosines and cosines, the Euler's formula says e to the I theta plus e to the minus I theta equals sines and cosines, right? I find this derivation to be fascinating. I never remember what a wave function is supposed to be. I always derive it because I always start with this fundamental assumption, and that's all you need. You can do it in 5 seconds. You'll never forget it.